Hello class. Today we're talking about the probability of disjoint and overlapping events. All right? And what this is really talking about, this is the probability of we want something that could fit into one of two groups. All right? Either we want the stuff out of this group or we want the stuff out of that group. As long as it comes out of one of those two, we don't care which one it is. All right? Disjoint events are mutually exclusive. Okay? They're either in one group or the other. They're not in both. An example of this is if you wanted to randomly pick a student from the high school who is either taking my class or they're taking calculus. Well, nobody is taking geometry and calculus at the same time, right? And so those are mutually exclusive. You can add up all of my students. You can add up plus all of the pre-calculus students. They're all good students, right? They're all favorable to stuff we're looking for. Right? So you add it all up, you take the probability of the whole thing. What else? And so that is disjoint events. Probability of the first thing plus the probability of the second thing. Okay? Second group. What if, however, we're looking for any student as long as they're either in my class or they're an athlete? Well, if I count up all of my students and then we count up all of the athletes, there are a lot of students that are in both places, right? I have a lot of students that are athletes. And so all of those students would be counted twice. And so that's going to mess it up. So since they're counted twice, I've got to subtract one of those double countings so that each student is only counted once. And that's what's happening here. The probability of the first thing, they're in my class, plus the probability of them being a student, minus the probability of them being both. Okay? So let's take a look at these. We want to randomly select a card from a 50 standard deck. What is the probability that it's either a 10 or a face card? As long as it's one of those two things, we don't care. It's all good. So probability that it's a 10. Well, there are 4 10s out of 52 cards. Probability that it's a face card. Well, there are 12 face cards out of 52 cards, and there is no overlap. There are no 10s that are also face cards. So we just have to add them up. This is 16 total cards out of 52. All right, so we've got 4 out of 52 plus 12 out of 52 is 16 out of 52, which simplifies as 4/13 or 0.308, so 30.8%. Okay, no overlap. What if instead we want them to be either a face card or a spade? Well, we still got those same 12 face cards, and we've got 13 spades, ace through king. But the problem with this, we can't just take, well, there's 12 plus 13 is 25 cards, right? Because we have these 3 cards here that are being counted in both groups. So it's being double counted. We have to subtract one of those countings. We've got to take these 3 out, right? Because we've already got them here, we don't want to pick them up in this 13. We just want the 10. So we have the 13 minus 3 gives us 10 plus 12. So we have 22 out of cards out of 52 that we're looking for, which we can simplify as 11/26 or 0.423 or 42.3%. All right. Now, slightly more complicated, but not much. We have 200 seniors in the graduating class. 113 of those are either varsity athletes or on the honor roll. We have 74 seniors on varsity. We have 51 seniors on the honor roll. What is the probability that if I randomly pick a senior, they will be both on varsity and on the honor roll? All right. Well, what we're going to do, we're going to go to our equation here. All right. Fill in what we know. Probability that it's either one or the other. Well, it gives me that. 113 are either one or the other. So that's 113 out of 200 that are A or B. Probability that they're an athlete. Well, it told me that. That was 74 varsity athletes out of 200 seniors. Probability that they are on the honor roll. Well, it told me that was 51 honor roll students out of 200 seniors. So we fill that in. Probability that they're both? Don't know. We've got to figure that out. So this is our variable. Just like in any other algebraic equation, we want to get this probability of A and B by itself, this missing term. So we add this to both sides. We subtract that just so that this can be positive. And there we go. So we have the probability is 74 out of 200 plus 51 out of 200 minus the ones that are either or, right? Which gives us 12 students out of 200 that are both on varsity and on the honor roll. Simplify that, it's 3 out of 50 or 0.06, so 6%. 6% of the graduating classes, both varsity and honor roll. Right? Now, what I want you to do, pause the video, work these three out. For number 3, remember we have 200 students and 51 on the honor roll. All right? Pause this, work these out, come back and check your answers. Now let's see how you did. Number 1, you should have 2 out of 13. Number 2, 4 out of 13. And number 3, you should have had 19 out of 200, which is 9.5%. All right. If you got those, great. You can skip ahead a little bit. If not, let's see what's going on. All right. So an ace or an 8. All right. Well, there are 4 aces, 1 for each suit. There are 4 8s, 1 for each suit. There are no aces that are also 8s, so they're mutually exclusive. We just got to add them up. And you can either simplify them here, or you could add them up as 8 out of 52 and simplify that. Either way, it's all good. Okay, so a 10 or a diamond. Well, there are 4 10s out of 52 cards. There are 13 diamonds out of 52 cards, and there is 1 10 of diamonds. So we got to take that one out because it got double counted, because it was in both groups. So 4 plus 13 minus 1 is 16 out of 52, which simplifies as 4 out of 13. All right. So number 3, probability that they are in the band or on the honor roll, we've got 64 out of 200. Probability that they're in the band is 32 out of 200. Probability they're on the honor roll is 51 out of 200 from the last slide, and we're looking for this. So you add that to both sides, subtract the 64 out of 200 from both sides, and then we can just take this, stick this in our calculator, and we have 19 out of 200 students that are both in the band and on the honor roll. All right? And that's how that works. And so it's not too bad. Now, sometimes, though, we are looking for it to be this and that. Not one or the other, but one thing and another thing. All right? And sometimes these can get a little bit complicated, but they're not too bad. All right? So here we have the American Diabetes Association says there are 8.3% of people in the United States who have diabetes. And suppose we've got some medical lab that's got a test that is 98% accurate if somebody has diabetes, and it's 95% accurate for someone who doesn't. We want to know what's the probability that if we pick somebody at random, the test diagnosis will be correct. All right. So what we're going to do is we need it to be, 1, we need to know the probability of if they have diabetes, and then the probability that if they have diabetes, it's also correct. Okay, so we're looking for this and that. Or the probability that they don't have diabetes and the diagnosis is correct. Okay, so again, we're looking for this and that. Okay, 2 different things. It has to be both. All right, and we're going to use a little tree diagram to show this. Okay, so population of the United States, we have 8.3% that have diabetes. Well, if 8.3% have diabetes, then it's 100% minus that, or 1 minus 0.083 is 0.917 that do not have diabetes. All right, and same thing here. If the person has diabetes, the test is 98% correct. All right, which means that it's 2% incorrect. If they do not have diabetes, it's 95% correct, which means that it's 5% incorrect. Okay. So what we need is the probability that it is correct here or that it's correct here. So we need to add these two together, right? Because it's this or that, and there is no overlap, right? It can't be over here and down there. No good. So we're going to add those up. But first we have to know what is the probability, total probability of event B given event A, right? Well, what this is not 98% of the total population. This is 98% of the 8.3%. All right. So it's 98% times the 8.3%. And anytime you want this and that to happen, you need to multiply the probabilities. All right. So it's 0.083 times 0.98. That is the probability of event A and event B, that someone has diabetes and they get the correct diagnosis. So now we need to add to that the probability that someone does not have diabetes and gets the correct diagnosis. So that would be 91.7% times 0.95%. 95% of 91.7%. So you're going to multiply those together. And then you add them up. And so you end up with a test that is 95.2% correct. Okay, so what I want you to do is answer these two questions here. I want you to pause the video, and I gave you the table there for number 4. Pause the video, work these out, then come back and check your answers. Alright, so problem number 4. You should have come up with 0.084 or about 4.8%. And so we're looking for the diagnosis to be correct. Incorrect. So what we have is event not be here or event not be this. So we need this probability plus the incorrect down here. So we need to figure out what this probability is, total out of the entire population of the United States. All right? So probability that they have diabetes, 8.3%, 0.083. Probability that they get the wrong diagnosis, 0.2. So we multiply those together because we want this and this. And we're going to add to that the probability that they do not have diabetes and get the wrong diagnosis. So 0.917 times 0.05. So now we have this and that, so we multiply them together. And we want this one or that one, so we take those two probabilities and we add them up. And we get 0.04751, or about 4.8%. Okay, so number 5. Basketball team leads at halftime 60% of the time. If they are leading at halftime, they win 80% of the games. But if they're not leading at halftime, they only win 10% of the games. And you should come up with a 52% chance of winning the season, winning any particular game in the season. So let's take a look at this. Probability of them winning leading at halftime times the probability that they win the game, given that they're leading at halftime. So they win 80% of the 60%. All right. Plus, they also win 10% of when they're losing at halftime. And if they're winning ahead 60% of the time, that means they are behind 40% of the time. So that's where this comes from. So they get 10% of those 40 games plus 80% of the 60% of the games. And you stick that in your calculator, you add it up, and you come up with the probability that they win is going to be 8.52, so 52%. All right. And that is probability of disjoint and overlapping events. It also gives you probability of if you want two things to happen at the same time, this and that. Remember, if you want A or B, you add them up and subtract the overlap, if there is any overlap. If you want A and B, then you need to multiply them like we did here. 60% of 80% of 60%. So you multiply them both together. All right. You multiply these two probabilities together because you want A and B. All right. A or B, you add the probabilities. A and B, you multiply the probabilities. All right. Make sure you subtract out any overlap. And I hope that helps. And I'll see you next time.